We'll start 11.6, which is the last section in chapter 11, the last section, and the topic here is inverse functions, okay? The topic of inverse functions is going to carry over to the next chapter, actually. When we get there, you'll notice that. Definition, it says that if f is a function, the inverse of f receives as input a number, f of x, it manipulates it and then outputs the value x. Now that is the exact opposite of a regular function, right? We know with a regular function, the input values are the x values and the output values are the f of x values. Remember, y and f of x mean the same thing. But here it's switched on us. Okay, the input is y and the output is x. Here's a note. If the variables are x and y, we just simply switch x and y when we begin computing an inverse. Okay. Whenever you see the word inverse, the first thing I want you to think of is switch x and y. Okay, that's what we're going to be doing in all the problems here when we compute an inverse. Let's take a look at problem 40. Here are the names and birth dates of 5 individuals. Find the inverse of this function. Okay, well, by the way, note that I do have a function. Here's the x's, here's the y. Does each x go to one y? Emily and Marie share the same birthday. That's okay, there's no problem with that, right? Each person has exactly one birthday. Nobody can have 2 different birthdays, that's impossible, okay? And so the fact that they share the same birthday, that's no problem. They each have one birthday, okay? So we do have a function. Now, it's all about switching x and y, so all I'm going to do in this problem is I'm just going to switch the 2 sides of the diagram. The birthdays would go on the left side, the friends would go on the right side, and I draw my correspondence arrows. And this picture here would be my answer. That would be the inverse of the function. I'm going to come back to that in just a moment, problem 40, but if we take a look at problem 41, the set of points that are listed here is given. Find the inverse of this function. Well, again, note that I do have a function. For each x, there's only one y, right? I don't have an x value going to 2 different y values. Now, when I compute the inverse, it will also be a set of points, and it's all about switching x and y. So all I would do here is I would just switch the coordinates on the points that are listed, and then list the new points. Okay, so that's going to be -2, 5, 4, 1, 0, 0, -27, -3. I'm just switching the coordinates. Here's a definition next. If the inverse of a function f is also a function, then f is called 1-to-1. Well, let's take a look at problem 42. Part A, is the function 1-to-1 in problem 40? All right, well, here's problem 40. We did have a function, right? And here's the inverse. The inverse is not a function, right? When I compute the inverse, this situation now, I don't have an x going to exactly one y. Lots of people can be born on January 26th, right? So just looking at the names listed here, we have an x value going to 2 different y values. You can't have that with functions. So the inverse would not be a function. Therefore, the function is not 1-to-1 in problem 40. How about part B? Is the function 1-to-1 in problem 41? Okay, so here is this set of points here, which I mentioned is a function. Okay, find the inverse of this function. We've done that, right? This set is my inverse. Notice how we do still have a function. Okay, like when I look at this set of points, each x is going to one y. So the inverse is a function, therefore the function is 1-to-1 in problem 41. All right, so 1-to-1 just simply means that the inverse is a function. When you switch x and y, Sometimes the inverse might be a function still, and sometimes not. You know, it just depends on what the original problem looked like. The next thing that we'd like to know is what's called the horizontal line test. Now, we talked about the vertical line test with functions. We've used that a lot, right? When you draw a function, you need to make sure it passes the vertical line test. Okay. The horizontal line test pertains to a one-to-one function. It says if every horizontal line intersects the graph of a function f and at most one point, then f is 1-to-1. All right, let's take a look at problem 43. The graph of a function f is given. We're going to use the horizontal line test to determine if f is 1-to-1. Here's part A. I've got the square function, right? Y equal x squared. Okay, is that, of course, that is a function because it passes the vertical line test. Now, is this function 1-to-1? No. This will fail the horizontal line test, right? If I swing a horizontal line down the graph, I'm not going to intersect the graph in only one point. Okay? Therefore, this is not 1-to-1. Now, what that means to us is that this function has an inverse, but that inverse would be some curve that would fail the vertical line test. The inverse is not a function. Let's take a look at part B. Okay, here's another function. This is the cube function. We looked at that in section 11.4, the cube function. And of course I do have a function, right, because it passes the vertical line test. This is y equal x cubed. Now, is this a 1-to-1 function? Yeah, it will be because it passes the horizontal line test. If I draw a horizontal line anywhere on the graph, I'm only going to intersect the graph in one point. So yes, this would be a 1-to-1 function. Now, what that means to us is that this function has an inverse, and whatever curve that looks like, it would be some curve that will pass the vertical line test. Okay, the inverse is a function. So the horizontal line test can be useful, you know, to determine if the inverse is a function, or in determining if you know, the function is 1-to-1 there. Okay, and I'm going to stop the video there.